Welcome to the chapter on antibodies. Today we will explore different types of antibodies and their functions. Let's start with IgM. It is a pentamer composed of 5 subunits joined together. IgM is the largest circulating immunoglobulin and they have exceptional binding capacity. How? Each subunit has 2 FAB regions. Notice here these are the FAB regions, giving a total of 10 antigen binding sites. The IgM pentamer as well as the IgG monomer will has the complement binding property. That is, the complement will bind to the antibodies only when the antibodies are attached to the antigen. Free antibodies do not activate the complement binding, preventing unnecessary tissue damage. Once this complement is bound, it acts by 3 ways. First one is it will form membrane attack complexes that punch holes in the pathogen. Secondly, they will enhance the phagocytosis through opsonization. And finally, they will recruit immune cells using anaphylatoxins like C3A and C5A. The IgM pentamer, once it binds to the antigen, it will undergo a conformational change, exposing the C1q binding sites. This is the IgE, but I was talking about IgM. IgG monomer, the specific classes like IgG1 and IgG3, they are also capable of efficient C1q binding after antigen attachment. The antibodies will bind complement only after antigen binding, never when free in the circulation. This prevents inappropriate complement activation and tissue damage. The IgM is the primary response indicator. That means the first antibody to appear, making it the gold standard for diagnosing acute infections. The question might be, what is the antibody to appear in congenital toxoplasmosis in neonates? Since this is the primary response indicator, the answer to that question is IgM. This is pentameric structure providing 10 binding sites. Pay attention, this is the FC fragment and FAB segment. Since this has 10 FAB segment, it has 10 binding sites, delivering the highest avidity. We have hyper IgM syndrome. This is the B cell with the MHC2. So it has phagocytosed the pathogen and made it into smaller peptide molecules expressing the peptide. This is the T cell with the T cell receptor as well as the CD4. So the primary stimulation is between the MHC class 2 as well as the T cell receptor. There is a secondary stimulation too. But in hyper IgM syndrome, the CD40 on the CD40 ligand has to attach with each other or bind with each other or has to be recognized so as to produce more antibodies. How does this happen? The CD40 receptor is present on the B cell, but the CD40 ligand is present on the T cell. The final activation happens after CD40 ligand and CD40 receptor are bound together. So once all three stimulation happens, then the B cell will start producing antibodies. Initially starting with IgM, later producing the specific antibodies. If there is a CD40 ligand deficiency in the T cell, then the B cell cannot switch classes as it normally used to do. Instead, it will lead to the overproduction of the first antibody that it produces. That is resulting in an hyper IgM syndrome. Now let's move to IgG, which is the most abundant antibody in our body. IgG dominates the memory response and it rises during chronic infection. Because it is smaller than IgM, IgG can cross the placenta, protecting the fetus. It accounts for nearly 80% of all circulating antibodies. Clinically, IgG is important in two scenarios. First, anti-D IgG is given to Rh negative mothers post delivery of Rh positive babies to prevent the hemolytic disease of the newborn. And second, IVIG therapy is used to treat immunodeficiencies and some viral exposures such as hepatitis B, varicella zoster virus, and compensates for immune deficiencies by neutralizing pathogens and toxins. IgA, that is the mucosal guardian. It is a predominant antibody in the mucosal secretions, respiratory tract, and gastrointestinal system. It is secreted by a dimeric structure joined by J chain. This question has been asked in the NBME. The GALT, that is gut associated lymphoid tissue, including the Peyer's patches, consisting of the Peyer's patches or aggregates of lymphoid tissue in the gut, that is responsible for protection against intraluminal pathogens. Peyer's patches are the predominant source of IgA producing cells. IgA deficiency is the most common hereditary immunodeficiency. It can present with recurrent cyanopulmonary infections, atopy, increased giardia, and associated with other autoimmune disorders too. It can cause anaphylaxis with blood transfusions. Why should it be? This is because the blood which is being transfused by the donor will be containing IgA antibody. Here that IgA antibody acts as an antigen to the recipient because the recipient doesn't have an IgA in it. So the IgA antibody is considered foreign. The recipient now begins to produce antibodies against IgA, that is anti-IgA antibodies. It will be mostly IgE antibody against the IgA. Therefore, the excess of IgE antibody which is developed against the donor IgA can cause anaphylaxis with the blood transfusions. This is the first point. The secondly, it can result in false negative celiac screening. It can cause false negative celiac screening. Why? To screen for celiac disease, we screen anti-tissue transglutaminase IgA. This anti-tissue transglutaminase is an IgA antibody. When that person is already having an IgA immunodeficiency, then anti-tissue transglutaminase IgA is also not going to increase. Therefore, even though they are suffering from celiac disease, the anti-tissue transglutaminase IgA is not increasing, thereby providing a false negative celiac screening. Let's see the other antibody, that is the IgE. In the picture, this is the IgE antibody. The IgA antibody molecules bind to surface receptors on the mast cells. This is a mast cell. Antigen cross-links the surface-bound IgE. This is the antigen. It cross-links the surface-bound IgE, triggering type 1 hypersensitivity. And there is rapid mast cell degranulation. The degranulation releases histamine and tryptase, causing immediate allergic symptoms. Elevated in allergies, in eosinophilia, as well as in helminth infections. You can find the IgA increased in the above said conditions. There is hyper IgE syndrome or Job syndrome that presents with findings with the mnemonic fated. F stands for facies, abnormal faces. A stands for abscess, staphylococcal abscess. T for teeth, retained teeth. E for hyper IgE, and D for dermatological issues. What is an isotype and what is an idiotype? Isotype is the antibody class determined by heavy chain constant region. This is the heavy chain and this is the light chain. So this type is the isotype. This will define what a general antibody function is. That's complement binding and its tissue distribution pattern. So each IgG will have this, all IgG will have this specific isotype. All the complement will bind with this isotype. And this isotype is responsible for the tissue distribution. Like this will be present in basophils, in mast cells. And it is made up of heavy chain. This is the light chain and these are the heavy chains. In idiotype, it is the unique antigen binding site in the variable region. It will determine precise antigen recognition. Two IgG antibodies can have different idiotypes because it is targeting different antigens, but the isotype will be the same. With this, we have come to the end of our antibody presentation. I am Dr. Veena, medical doctor with a passion for teaching. I mentor young graduates, medical graduates. If you like my slides, I will be happy if you show it by a thumbs up. And if you want me to mentor you, if you are a medical graduate or if you are preparing for MLE exams, I will be delighted to do it. Send me a comments. Have a good day. All the best for your exams.